Again, so the first one, the integral of dx is equal to x plus c. So if we will get the derivative of the integral dx, that's x plus c. That's the only possible example that we could give. Okay, so another theorem, the integral of x raised to n dx is equal to x to the n plus 1 all over n plus 1 plus c. Again, this is the inverse of the power rule of differentiation. Here in anti-differentiation, we will add 1 in the exponent and we will take n to the denominator plus 1. So using that theorem, we will determine the following antiderivatives. So the integral of x to the 6 dx, and number 2, the integral of 1 over x to the 6 dx. So again, so the integral of x raised to the 6 dx, so we will add according to our theorem, x to the n dx is x to the n plus 1. So the n here is 6, so 6 plus 1, and then we will take that exponent in plus 1 to our denominator. So 6 plus 1 to our denominator plus c. So 6 plus 1 is 7. So 7 in the numerator, I mean in the exponent, and 7 in the denominator. So the final answer is x to the 7 all over 7 plus c. That's the antiderivative of our function. So using the same theorem, for number 2, 1 over x to the 6 dx. So in order to use the theorem number 2 or letter B, we will, this is a rational function, we will apply, so we will convert it into a power function to use the rule or theorem number 2. So 1 over x raised to the 6 is equivalent to x raised to negative 6. So from this one, we will use our theorem, which states that our exponent plus 1 over exponent plus 1. Okay, so x raised to negative 6 plus 1 over negative 6 plus 1 plus c. So x raised to negative 5 over negative 5 plus c. So the final answer is equal to negative 1 over 5x to the 5th plus c. So another part of the theorem, that's the integral of a times f of x dx is equal to a times the integral of f of x dx. So it is a constant rule. Now, you will determine the following antiderivative. So the integral of 3 dx, and number 2, the integral of 4 square root of u du. Okay, so for number 1, the integral of 3 dx, so using our, this is a constant rule in antiderivative, so that's the integral of 3, and then, so it becomes 3 times the integral of dx. And using the first theorem, so the integral of dx is x plus c. So the final answer is 3x plus c. Another example here, the integral of 4 square root of u du. So before we could use the we will separate this one using our constant rule, which is 4 times the integral of the square root of u. So we don't have a rule for the radical side, so we will convert it into a power function to use the theorem B or number 2. So it becomes from square root of u, it becomes x raised to 1/2. So now it becomes 4 times the integral of x raised to 1/2 du. So using the rule, the theorem rule, I'm sorry, it should be not x, it's u. I've edited it. Um, so u raised to 1/2. So using the second theorem, so the exponent plus 1 over the exponent plus 1. Our theorem number 3, which is the constant, so 4 times the u here, and then 1/2 raised to 1/2 plus 1, and then this 1/2 plus 1 will become the denominator, so over 1/2 plus 1 plus c. So this becomes 1/2 plus 1 is 3 over 2, and also our exponent is 3 over 2. So it becomes 4u raised to 3 over 2 all over 3 over 2 plus c. So 2 times 4, that's 8. So 8u raised to 3 over 2 over 3 plus c. So this is the final answer. Okay, so the last theorem on antidifferentiation. So the integral of f of x plus minus g of x dx is equal to the individual antiderivative of a function. So integral of f of x dx plus minus integral of g of x dx. Okay, so we have three examples here. So we will determine the following antiderivatives. So the integral of 12x squared plus 2x dx, the integral of t times 2t minus 3 squared of t dt, and the integral of x squared plus 1 all over x squared dx. Okay, so again, for number 1, so the integral of 12x squared plus 2x dx. So we will have the integral, or we will use the fourth theorem, which for addition and subtraction, we will just have the individual integration or antiderivative of the function. So the 12 times the integral of x squared, so that's 12, and then x squared, so 2 plus 1 is 3 all over the exponent, which is 3, or 2 plus 1, that's 3. So that's 12x cubed all over 3. And then the second part is the 2x, so 2 times the derivative of x, or integral of x dx, so that's the exponent here is 1, so 1 plus 1 is 2, and then 1 plus 1 is 2 again in our denominator. So that's 2x squared all over 2 plus the c. Don't forget the c again. So 12 divide 3 is 4, so 4x cubed plus 2 divide 2 is 1, so x squared plus c. So this is the answer, 4x cubed plus x squared plus c. Next is the integral of t times 2t minus 3 squared of t dt. So it's a multiplication, t n times the 2t minus 3 squared of t. So since we don't have a product rule here in antiderivative, so we will just distribute the t to our another um, term here. So t times 2t is 2t squared, t times negative 3 squared of t, that's negative 3t raised to 3 over 2. So from that, we will use the fourth theorem, which is the individual the antiderivative of a function. So 2t squared, so 2 integral of t squared, that's 2 plus 1, that's 3 all over 3. So 2t cubed over 3 minus the 3 integral of t 3 raised to 3 over 2. So 3 over 2 plus 1, that's 5 over 2 over 5 over 2. Okay, so the 5 over 2 in the denominator here. So the 2 times the 3, so it becomes 6. So 60 raised to 5 over 2 all over 5. So this is the answer. 2t cubed all over 3 minus 60 5 over 2 over 5 plus c.